Welcome back to Tech Insights, your go-to source for the latest in technology trends and innovations. In today's episode, we'll be diving into the fascinating world of quantum computing, how it works and why it matters. To understand the basics of quantum computing, we need to dive into the principles of quantum mechanics. One of the fundamental concepts in quantum mechanics is the wave-particle duality, which states that particles can behave both as waves and as particles. This property is described by a mathematical object called a wave function, which represents the probability of finding a particle in a particular state. Qubits, the building blocks of quantum computing, are particles that exhibit this wave-particle duality. Unlike classical bits that can only exist in one state at a time, either 0 or 1, qubits can exist in a state of superposition, meaning they can be both 0 and 1 at the same time. This might seem strange, but it allows quantum computers to perform certain calculations much faster than classical computers. For instance, a quantum computer can factor a large number exponentially faster than a classical computer, which would take an impractical amount of time to solve. This has important implications for cryptography, which relies on the difficulty of factoring large numbers to keep information secure. But how do qubits work, and how are they different from classical bits? A qubit can be represented as a particle with a spin, which can be either up or down. But unlike a classical bit, which is either up or down, a qubit can also be in a superposition of the two states. This means that a qubit can represent both a 0 and a 1 at the same time, allowing for much more powerful computations than classical bits. Another important concept in quantum mechanics is entanglement, which refers to the phenomenon where two particles become linked in a way that their states become correlated. This means that measuring the state of one particle instantly determines the state of the other, regardless of the distance between them. Entanglement is one of the key features of quantum computing that allows it to perform computations much faster than classical computers. Now that we understand the basics of quantum computing, let's dive into why it matters. Quantum computing has the potential to revolutionize many fields, from drug discovery to cryptography to climate modeling. For example, quantum computers could enable the rapid simulation of molecular interactions, potentially accelerating the development of new drugs. They could also help improve weather forecasting and climate modeling, leading to better predictions and more accurate simulations. Moreover, quantum computing could lead to significant advancements in artificial intelligence and machine learning. With its ability to process and analyze massive amounts of data, quantum computing could help AI systems identify patterns and make predictions at a speed that is not feasible with classical computers. This could have huge implications for fields such as healthcare, finance, and transportation. However, despite the exciting possibilities of quantum computing, there are many challenges that must be addressed before it can become a practical reality. One of the biggest challenges is maintaining the stability of qubits, which are highly susceptible to external factors such as temperature and noise. Scientists and researchers are working hard to develop new materials and techniques that can help mitigate these challenges. Quantum computing is still in its early stages, but the potential benefits are too great to ignore. As researchers continue to make progress in this field, we can expect to see more exciting developments in the coming years. That's all we have time for today. Thank you for tuning into Tech Insights, and we hope you enjoyed learning about quantum computing. If you have any questions or comments, please feel free to reach out to us on social media. Until next time, keep exploring the fascinating world of technology.